All right, let's dive right into this explainer. Today, we're demystifying exactly how Python makes decisions and elegantly stores data. We're going to explore the underlying logic that powers your favorite applications and look at how developers manage literal mountains of information without losing their minds. Here's our roadmap for today. First, conditional logic in Python. Second, why we need lists. Third, understanding list indexes. And finally, modifying your Python lists. Section 1, conditional logic. In Python, or as we like to call it, the hungry developer. To really wrap our heads around conditionals, let's look at the ultimate everyday scenario, deciding what to eat when you are absolutely starving. Imagine our developer is hungry, and the program uses an if statement to verify that. But here's the catch. Our developer completely rejects both fast food options available, burgers and pizza. So what exactly happens in the code when those preferred conditions just aren't met? Well, the answer? Sleep without eating. Our code uses an else statement to catch this exact scenario, completely bypassing the pizza and burgers to output this specific result. You see, the if and elif statements look for specific true conditions, but when all those fail, the else statement acts as our safety net. It basically says, hey, none of the above were true, so let's just run this default block of code instead. And this brilliantly illustrates the difference between two absolutely critical logical tools, the AND versus the OR operators. The AND operator strictly requires both conditions to be true. You gotta be hungry and love burgers for the code to run. On the flip side, the OR operator, it's happy if just one is true. Hungry and like burgers or pizza, bam, you get to eat. Understanding this distinction is literally the bedrock of controlling flow in Python. Moving on to section 2. Why we need lists. Let's look at this through the eyes of a grocery shopper. Okay, imagine coding the clunky, old-school way. You'd have to create a brand new variable for every single grocery item. Item 1 is cake, item 2 is eggs, item 3 is juice. Imagine doing this for a list of 50 items. It's painful, it's messy, and honestly, it scales terribly. We'd spend our entire day just typing out variable names instead of actually building cool software. So the real game changer here is the Python list. It's an elegant, type-safe data structure enclosed in square brackets that holds multiple items simultaneously. By defining it as a list of strings, using that string keyword, we're explicitly telling Python, hey, this list will strictly contain text. It puts all our items, the cake, the eggs, the juice, the bread, into one neat, super manageable box. Section 3, understanding list indexes. This is all about finding your groceries once they're put away. So let's talk about how we actually find specific items in our new list. Now, you might notice the counting system in Python is a little weird. Python actually starts counting at 0. This is what we call an index. So our first item, cake, sits at index 0. Eggs are at index 1, juice at index 2, and chips at index 3. If you ask Python for item number 1 thinking you're going to get cake, it will literally hand you eggs instead. You really want to avoid this common pitfall. While index mapping starts at 0, checking the total length of the list using the len function starts counting at 1. So if you have 4 items, len returns 4. But remember, the highest index in that list is only 3. Honestly, mixing up the index number with the length number is a total rite of passage for every developer. Now, what if you don't want just one item, but a specific chunk of them? Well, if you only want the first 4 items, you can slice the list using colon notation. Writing 0:4 tells Python to grab everything starting from index 0 up to, but excluding, index 4. It's an incredibly fast and powerful way to segment your data. And how do we check if we actually remember to add something to our list? By simply using the in keyword, we can ask Python to check for membership, and it will instantly return a Boolean true or false. Is oil in the shopping list? Python searches behind the scenes. If it's there, true. If not, false. It's highly readable and feels almost exactly like plain English. Section 4, modifying your Python lists, or changing the order. A real grocery list changes as you walk down the aisles, right? Well, Python lists are dynamically designed to do exactly the same thing. We can manipulate our data using built-in commands. For example, we can use append to stick flour directly onto the end of the list.
We can use insert to slide T right into the middle at a specific index. And we can use pop to remove chips entirely out of the list based on its index. And the best part? The list instantly resizes itself.
Notice the difference between these actions, though. Inserting requires you to formally name the item you want to add. You literally have to tell Python what to put in the box. But removing with pop, that only requires the index number. Why? Because Python already knows what's in that box. You just point to the spot, say, remove that, and Python handles the whole shebang smoothly.
We've covered some incredible ground today. We've mastered conditional logic, and we've organized our chaos using the awesome power of lists. But this leaves us with a fascinating final thought. Now that you can store and modify dozens of pieces of data in a single list, how do we process all of it at once without repeating our code? Well, the answer lies in loops, and that is exactly where your programming journey should take you next. Keep exploring, keep questioning, and we'll see you on the next explainer.